So sometimes what happens with molecular formula questions is they end up a little bit more like the one I've just found here on the left, where they don't actually give you the empirical formula, and you actually need to calculate that first. So sometimes that's two steps. So step one's calculate the empirical formula, and then you can use the empirical formula to work out the molecular formula. So we're going to do that with this question here. So just like we started with before, we've got a major textile dye manufacturer developed a new yellow dye. The dye has a percentage composition of 75.95% carbon. So remember, we're going to consider 100 grams, which would mean that we have the mass of carbon is equal to 75.95 grams. The mass of nitrogen is equal to 17.72 grams. And the mass of hydrogen is equal to 6.33 grams. All right, what we can do now is we can work out the empirical formula by calculating the number of moles of these things. So let's do that. So the number of moles of carbon is equal to the mass of carbon on the molar mass of carbon, and which is equal to 75.95 grams divided by 12.01 grams per mole. I'm just going to do that on the calculator really quickly. And we get 6.32389673. Really important. It's really important here to actually keep all of those significant figures because they could become important later. If you cull them too soon, you can end up with a percentage error and it could really throw off your calculations. Let's do the same for the other two. So just moving this up a little bit, I'll just change the camera angle. So my number of moles of nitrogen is equal to mass on molar mass is 17.72 grams divided by 14.01 grams per mole. Now it's really important here as well not to think that nitrogen's N2 here. It's just for the single nitrogen. It doesn't exist in its molecular form. We're talking about inside a compound that contains these three things. So 17.72 divided by 14.01, and we get 1.264810849. Once again, just check this and we get moles. Always thinking about our units. The last one I'll just do here is our number of moles of hydrogen. Mass on molar mass, so 6.33 grams divided by 1.008 grams per mole. And this is equal to 6.33 divided by 0.008, and you get 6.279761,905. Once again, moles. Now let's work out some ratios really quickly. So I'm just going to draw a little line here. The number of moles of, let's have a look at the two things that are quite similar. You'll notice already that you can probably see that the number of moles of hydrogen is really similar to the number of moles of carbon. You're probably going to get a ratio of 1 to 1. What we're probably looking for here is, let's work out the nitrogen to carbon ratio. So the number of moles of carbon to the number of moles of nitrogen. You're often going to be better off putting the one with the larger number of moles above, so you don't get a strange fraction. So you're going to get 6.32389673 moles divided by 1.264810849 moles. I'm just going to do that quickly on the calculator. 6.32389673 divided by 1.264810849, and we get 4.999, very close to 5, 875482. Now moles and moles cancel. It's just a ratio. right? So what this is really saying is that it's a 5-to-1 ratio of carbon to nitrogen here, which is good to know. I can already see that if I do carbon by hydrogen, I'm going to get a 1-to-1 ratio. They're both about 6.3. There's not a huge point in doing that. So my empirical formula here is, well, the number of moles of carbon and nitrogen are the same, and my number of moles of carbon and nitrogen is 5-to-1. So what we really have is this C5, H5, because they're 1-to-1, N is my formula so far, but that's not necessarily my empirical formula. So I'm just going to move this over here. What we need to do now is we need to work out what the mass of that would be. So the molar mass of C5H5N, just like we did before to work out the molecular formula, we need 5 carbons. So the molar mass of this is equal to 5 times 12.01 plus 5 times 1.008 plus 14.01. So that's my C5H5N. Just make sure you can see this. So I'm just going to do that on the calculator quickly. And you can put it in the calculator exactly as I've written it here. That's why I tend to do it that way. 12.01 plus 5, 1.008 plus 14.01. And I get 79.1 grams per mole for this compound. And if we look it up, it actually says over here, it's 240 grams per mole. So let's see what fraction of that we have. So if we work out the number of units, as we said before, the number of units of C5H5N, how many of these fit into this bigger compound? It's 79.1 grams per mole divided by 240 grams per mole. And that works out to be 0.329583333, which tells me that this is what we're talking about here. This is about a 1-to-3 ratio. If you go and do this the other way and you go 240 divided by 79.1, you get 3.03. So it is a 1-to-3 ratio, which tells me that this is actually a third of what we should have. So let's multiply everything by 3. So the molecular formula for this ends up being actually 3 times C5H5N, and we actually get C15H15, and then N3 would be our molecular formula.